Good morning to everybody. Listen here, students. Properties on modulus function. Modulus function is very important, and its properties are also very important. That is, properties on modulus function one by one. That is first one, the modulus of a complex number, the modulus of a complex number and its conjugate, the modulus of a complex number and its conjugate are same. The modulus of a complex number and its conjugate are same. That is modulus of a complex number and its conjugate of a modulus. The modulus of a complex number and its conjugate is equal or same. Let Z is equal to A plus IB be a complex number and its conjugate A minus IB. That is, take modulus on both sides. Modulus of Z is equal to modulus of A plus IB and modulus of its conjugate is equal to A minus IB. That is, you know that definition of modulus real part square plus imaginary part square. Modulus of Z formula square root of real part square plus imaginary part square. A real part is what? A square. Imaginary part is what? B square. Here square root of real part is what? A square. Imaginary part is what? Minus B whole square is equal to square root of A square plus negative square always positive B square. Value is same. Both are same. That is, modulus of Z is equal to modulus of Z bar. The modulus of complex number and its conjugate both are same. That is an example. That is example. Let Z is equal to 1 plus I 1 plus I. Z bar is 1 minus I. Write its conjugate. Take modulus on both sides. Modulus of Z is equal to, here write real part square plus imaginary part square. This modulus of Z bar real part square plus imaginary part square. Real part is 1, imaginary part is minus 1. 1 square is 1, 1. Value is what? Root 2. This value is what? 1 square, 1 square. 1 plus 1 is 2. Both are same. Conjugated complex and its conjugate. For the modulus of complex and its conjugate, both are same. Next, property number 2. Second property, if Z is a complex number, then Z into Z bar, Z into Z bar is equal to modulus of Z whole square. If Z be a complex number, is a complex number, then Z into Z bar is equal to modulus of Z whole square. Verify that one. Let Z be a complex number, A plus IB, and its conjugate Z bar is A plus IB. Its conjugate is A minus IB. Verify that one. LHS is equal to RHS. That is Z into Z bar is equal to modulus of Z whole square. LHS, product of complex and its conjugate, is equal to modulus of Z whole square. That is, Z is what? A plus IB into Z bar is A minus IB is equal to modulus of A plus IB. This is the symbol for modulus. Modulus symbol. That is A plus B, A minus B. Do you know that A plus B, A minus B value is A square minus B square. That is the formula. A is what? A square minus B is what? LB is equal to modulus definition, square root of square as it is This is real part square plus imaginary part square. That is the definition of modulus. Here e square minus I square into b square. Square and root cancel is equal to a square plus b square. A square as it is, I square value. I square value is what? Minus 1. I square is minus 1. Minus minus plus b square is equal to b square plus b square. LHS is equal to RHS. Verify this property. Any doubt? That is the Z into Z bar is equal to modulus of Z whole square. These properties helps to the CT. Properties are helps to the CT point of view. Next, property number 3. Property number 3. That is the modulus of a complex number z and minus z are same. The modulus of a complex number z and minus z are same. That is modulus of z is equal to modulus of minus z. That is the meaning. Let z be a complex number, a plus ib, a plus ib. Minus z be a complex number, apply minus a minus ib. Z is equal to a plus ib, minus z is what? Minus a minus ib. Take modulus on both sides. Modulus of z is equal to, apply this property, modulus of minus z. This is the mod definition. This is also a mod definition. Modulus of a plus ib, modulus of minus a minus ib. Modulus definition. It is a square root of real part square plus imaginary part square. Square root of real part square plus imaginary part square. That is square root of a square plus b square is equal to square root of negative square always positive. LHS is equal to RHS. Therefore, the modulus of complex number and modulus of minus z are same. The modulus of a complex number z and minus z are same. That is one example. Z is equal to 1 plus I, and minus z is equal to minus 1 minus minus 1 minus 1. That is the formula. Modulus of z is equal to modulus of minus z. This modulus of 1 plus I is equal to modulus of minus 1 minus I. Modulus definition real part square plus imaginary parts. Modulus definition real part square plus imaginary part square. Negative square always positive. Negative square always positive. That is root 2 is equal to both are same. That is fourth one. Fourth one, that is properties. The complex number is 0. A complex number. A complex number is 0. Is 0. A complex number is 0 if and only if and only if its modulus is 0. Modulus is 0. A complex number is 0 if and only if its modulus is 0. Let Z be a 0 complex number. 0 plus I0. This is a 0 complex. Take modulus 0, value is what? G. Yes. Modulus of 0 complex is G. That is the value. Next. Here note first point, modulus of Z1 into Z2 is always equivalent to modulus of Z1 modulus of Z2. Modulus of Z1 into Z2 is equal to modulus of Z1 into modulus of Z2. That is, in general, suppose modulus of Z1 into Z2 into Z3 into Z4 up to Zn is equal to modulus of Z1 modulus of Z2 modulus of Z3 up to modulus of Zn. Into is there. For example, find the modulus of 1 plus I into 2 plus 3I. 1 plus I into 2 plus 3I. Addition and subtraction is not allowed in modulus. Separately modulus only affect product and division. Here let 1 plus I into 2 plus 3I is there. Find the modulus of, let the modulus of is equal to according to definition of product of two complex. This treat as Z1, this treat as Z2. Modulus of Z1 into Z2. Modulus of Z1 into Z2. Modulus of Z1, modulus of Z2. This is modulus of 1 plus I into modulus of 2 plus 3I. Z1 into Z2. Modulus of Z1, modulus of Z2. This is the definition of modulus. There is modulus. Definition is what? Square root of. In this place, real part is what? 1. Imaginary part is what? 1. First modulus. Second modulus, real part is what? 2. Imaginary part is what? 3. That is square root of 1 square is 1. 1 square is 1. 2 square is 4. 3 square is 9. Then is equal to modulus. First modulus 1 plus 1 root 2. Second modulus root 13. Do you know that root A into root B can written root AB formula is equal to root 2 into 13 is equal to 13 to the 26. Any doubt? Suppose here that is in general example number 2. Suppose find the modulus of the modulus of 1 plus I 2 plus I 3 plus I. So continuous product n plus I is there, suppose. In general, suppose first complex, second complex, third complex, fourth complex, nth complex is suppose in this form. Very simple. Keep in your mind. That is, find the modulus of. Yes, take modulus. Modulus of. This is the definition of modulus. Keep in your mind. Modulus of 1 plus I into 2 plus I into 3 plus I into n plus I. Modulus. Do you know that the modulus of Z1 into Z2 into Z3 into Zn is equal to each particular modulus, This can be expressed in the form of is equal to each particular modulus of 1 plus I, modulus of 2 plus I into modulus of 3 plus I into modulus of n plus I. This is, keep in your mind, sometimes asking this question in the CT, that is the modulus of 1 plus I, 2 plus I, 3 plus I up to so on n plus I. By using these properties of modulus of a complex number, that is very important point of view, CT point of view, that is separate modulus, separate modulus, separate modulus, separate modulus. Here we know that the definition of modulus, apply the definition of modulus is what? Square root of real part square plus imaginary part square. In this place, real part is what? 1. Imaginary part is what? 1. Here real part is what? 2. Imaginary part is what? 1. Here real part is what? 3. Imaginary part is 1. Separate modulus 2 square plus 1 square. Separate modulus 3 square plus 1 square into up to so on square root of n square plus 1 square. This is the definition of modulus, that is root 1 plus 1, 1 square plus 1 square, 1 square is 1, 1 square is 1, 2 square is 4 plus 1, 3 square 9 plus 1, here n square plus 1. We know that is, here if you first simplify, root 1 plus 1, 2, root 5, root 10 into root n square plus 1. Here we know that is the one condition, root A, root B, root C, root D, root suppose Z. This take at a time root A into B into C into D into up to small Z. This is the formula. Root A, root B, root C up to root Z. This can be written in the form of at a time square root of that is 2 into 5 into that is 10 into up to so on n square plus 1. This is the complete form. That is the modulus of this. Without general, product of 2 is there, product of 3 is there, product of 4 is there, product of 5 is there. Each particular, suppose find the modulus of 1 plus I, 2 plus I, 3 plus I, 4 plus I, 5 plus I, 6 plus I, whatever it may be, n plus I. This is the general solution of this one. Find the modulus of this. That is the formula for the modulus. This is Z1, this is Z2, this is Z3, this is Zn, this is Zn. We know that The property of modulus, modulus of Z1 into Z2 into Z3 up to so on Zn is what? Particular modulus of Z1, modulus of Z2, modulus of Z3, modulus of Zn. That is modulus of 1 plus I, modulus of 2 plus I, modulus of 3 plus I, up to so on modulus of n plus I. We know that the definition of modulus is what? Square root of real part square plus imaginary part square. Here real part is what? 1. Here imaginary part is what? 1. Here real part is what? 2, 2 square. Imaginary part 1, 1 square. Real part 3, 3 square. Imaginary part 1, 1 square. Real part n square. Imaginary part 1, 1 square. That is, if you square simplify, root 2, root 5, root 10, up to so on, root n square plus 1. We know that is root A, root B, root C, up to so on, root Z value is what? At a time root. That is the formula. At a time root, here 2 into 5 into 10 into up to so on, n square plus 1. This is the value. Next, that is here CT point. Suppose another one example take. Example number 3. Find the modulus of here 1 minus I, here 2 minus 3I, 1 minus I into 2 minus 3I. Solution. The modulus of 1 minus I into 2 minus 3I modulus is equal to modulus of Z1 into Z2 is what? Modulus of Z1. Modulus of Z2. Separate modulus. This is Z1, this is Z2. This modulus of Z1, modulus of Z2. This can be written, we know that the definition of modulus, that is square root of, here real part is what? 1 square. Here imaginary part is what? minus 1 square. Here real part is what? 2 square. Here imaginary part is what? minus 3 square. Real part 1, imaginary part minus 1, real part 2, imaginary part minus 3, square. That is 1 square is 1 square is 1. That is 2 square is 4, 3 square is 9. Is equal to root 2 root 13. Clear? Next. Suppose product is over division. Division form is what? Note. That is modulus of Z1 divided by Z2. Modulus of Z1 divided by Z2. Modulus of Z1 divided by modulus of Z2. Here modulus of Z2 not equal to 0. If denominator there is no 0. Clear? If denominator is 0, any number by 0 is what? Infinity. That reason denominator there is no 0. Suppose numerator is 0, 0 by any number is 0. But denominator not equal to 0. Denominator Z2 is not equal to 0, non-zero complex. That is, take one example. This modulus of Z1 by Z2. It is verification, separate is there. One example. Find the modulus of 1 plus I divided by 1 minus I. Suppose find the modulus of 1 plus I divided by 1 minus I. Let Z is equal to 1 plus I divided by 1 minus I. This is the complex number. Take modulus is equal to, take modulus on both sides. This is the modulus definition. This is the modulus definition. Understood? Here numerator is there, denominator is there. Numerator is there, denominator. According to definition or according to note, this can be written separate numerator modulus, separate numerator modulus, separate denominator modulus, separate numerator modulus, separate denominator modulus. Here separate modulus, separate modulus. That is modulus definition. Square root of real part 1, imaginary part 1. Square root of modulus definition, real part 1, imaginary part minus 1. That is 1 square, 1 plus 1, 1 plus 1. That is root 2 by root 2 is equal to what? 1. Because condition, the modulus of complex and its conjugate are same. That is property number 1. The modulus of complex and its conjugate are same. If you suppose in examination, suppose CT point of view is there. Suppose modulus of this. Here, find the modulus of this direct. Here complex number is what? 1 plus I. Conjugate is what? 1 minus I. Property number 1, keep in your mind, the modulus of complex and its conjugate are same. Get cancelled. Value is what? 1. The modulus of complex and its conjugate are same. Get cancelled. Value is direct. CT point of view. Here theory is there. If you solve and simplify, find the value. Suppose same question asking in CT. If you keep in your mind property number 1, the modulus of complex and its conjugate. The modulus of complex and its conjugate are same, and it is 1. Understood? And take next example number 2. Division form. Some examples is there. Suppose here find modulus of, this is the symbol for modulus, 1 divided by 1 plus I. Find 1 divided by 1 plus I. It is understood. Find 1 divided by 1 plus I. Solution, let modulus 1 divided by 1 plus I. This is what? modulus definition. This is the modulus. We know that the modulus of Z1 divided by Z2 is equal to what? Modulus of Z1 modulus of Z2. Numerator separate numerator modulus of 1 divided by modulus of denominator 1 plus I. Separate modulus. Modulus of 1, that is purely real is there. Modulus of 1 is always 1. That is modulus of denominator 1 plus I, real part square plus imaginary part square. In this place, real part is what? 1. Imaginary part is what? 1. This is here 1 divided by square root of 1 plus 1 is equal to 1 by root 2. Separate modulus. Next example. Some modulus examples is there. Example number 2 is what? Example number 3. Here 1 plus 2y, find modulus of 1 plus 2y divided by 1 minus 3. Solution: let modulus of 1 plus 2y divided by 1 minus 3i at a time is equal to, we know that definition of modulus of Z1 by Z2, modulus of Z1, modulus of Z2, modulus of numerator, modulus of denominator, modulus of numerator, modulus of denominator. We know that modulus definition is what? Square root of real part is what? 1. Imaginary part is what? 2. Square root of real part is what? 1. Imaginary part is what? Minus 3. Negative square always positive. Square root of 1 plus 4. Square root of 1 plus 9 is equal to root 5 divided by root 10. Here root 5 by 10 can written in another form, root 2 into root 5. Simplified, there is 1 by root 2 form is there. That is here. It is enough. Extra point of view, root 5, then root 10 can written, root 2, root 5 that cancel, 1 by root. That is it. It is here, this type of examples here is there. That is helps to the theory plus CT. That is modulus of 1 by 1 plus I, modulus of 1 plus 2I divided by 1 minus 3. Here are both type asking, find the modulus or symbolically. That is example number 4. Find modulus of here minus 1 divided by I, minus 1 divided by I. It is note according to note, minus 1 by I is what? Plus I. Otherwise, if you modulus solution, let modulus of minus 1 divided by I. Separate modulus numerator, separate modulus denominator is equal to modulus of minus 1. Here, in general, modulus of minus a is equal to what? Plus 1. Understood? Modulus of minus 1 is always plus 1. Here, modulus of I, real part square plus imaginary part square. In this place, real part is 0, imaginary part is what? 1. 1 is there, root 1 square is 1. 1 by 1 is equal to what? 1. Root 1 is 1. Next, example number 5. Find modulus of modulus of 2 plus 3i divided by 1 minus I. This is for your homework. Modulus of that one, that is homework you do in your home. It is this is solving procedure. Modulus of numerator, modulus of denominator. Modulus of numerator, square root of real part square plus imaginary part square. Denominator, square root of 1 square plus minus 1 whole square. Negative square always positive. 4 plus 9, this is 1 plus 1. Square root of 4 plus 9, square root of 1 plus 1. That formula is there. It is homework is there. Do your home. Next, here, example number 6. That is 2 marks. Find the modulus of that is 1 plus I divided by 1 minus I minus 1 minus I divided by 1 plus I. That is carefully solved. That is 2 marks question. Just middle is minus is there. If you don't apply modulus of this, here middle sign is minus is there. In modulus, positive, negative not allowed in separate. Only for separate here multiplication and division. Here solution modulus of this one, that is let here modulus of 1 plus I divided by 1 minus I minus 1 minus I divided by 1 plus I. Here, this type of examples, keep in your mind, middle is minus is, don't take modulus, 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 don't take, not consider in subtraction. First of all, this is completely simplified. If middle sign, addition or subtraction, do apply for the LCM. Here, next step, go for LCM. Next step, go for LCM. LCM is what? That is, your LCM is LCM 1 minus I into 1 plus I. 1 minus I into 1 plus I. Here, next, that is LCM, this place absent for 1 plus I. Here, this place absent for 1 minus I. 1 minus I. That is 1 plus I into 1 plus I, LCM part, minus 1 minus I into 1 minus I. Modulus. This is the mod symbol. This is the mod symbol is there. Not necessary. That is, do you know that in general, suppose here x by a minus y by b is there. Suppose LCM is ab is there. Suppose here multiply by b, here multiply by a. Keep it understood. This type is there. Here, that is, if LCM, there is another form. Suppose x by a minus a by x in this form. LCM is what? A into x. Here absent for x. Here absent for x square, a square. If you are interested. Here, next step, x into x, a into a, 1 plus I, 1 plus I, 1 minus I, 1 minus I, here 1 minus I, 1 plus I. Next is, that is, modulus symbol as it is. Here 1 plus I, 1 plus I, 1 plus I whole square, 1 plus I whole square minus 1 minus I, 1 minus I, 1 minus I whole square. Denominator. Do you know that denominator, that is a minus b, a plus b. This treat as a minus b, this treat as a plus b. Do you know that a minus b, a plus b, that is here a minus b, a plus b, this can be expressed a square minus b square. 1 minus I, here 1 plus I. This can be written 1 square minus I square. 1 square is 1. I square value minus 1. Minus minus plus. That is denominator A square minus B square. Next, that is here A plus B whole square, A minus B whole square. Do you know that A plus B whole square formula? Do you know that A plus B whole square formula? A square plus B square plus 2AB. A square value is what? Minus 1. Value is what? 2. Similarly, here 1 minus I whole square value is what? It is minus 2y. 1 plus I whole square is plus 2y. 1 minus I whole square value is what? Minus 2y. This can be expressed in the form of, that is, here 1 plus I whole square is what? Express or direct. Here A square plus B square plus 2AB minus A square plus B square minus 2AB. 1 square 1, I square value minus 1, minus minus plus, because I square value is what? Minus 1. Here I square value is minus 1, plus 1 minus 1, plus 1 minus 1 get cancelled, is equal to modulus of 2y minus minus plus 2y divided by 2. 2y is equal to what? 4i divided by 2. 2 ones are 2 2s are modulus of 2y. Modulus of 2i is what? 2. Modulus of 2i is what? 2. Here, because modulus of ib is equal to what? B. Modulus of 4i, 4. Modulus of 10i, 10. Modulus of minus 10i, 10. Modulus of minus 4, 4. Modulus of plus 4, 4. That is modulus of 2i is what? 2. This is the for the modulus of that one. We will explain once again. That is, find the modulus of 1 plus I divided by 1 minus I minus 1 minus I divided by 1 plus I. Here, this place, let this is the question. Modulus is there. Modulus is there. Middle sign minus is there. Do apply for the LCM. LCM is what? Here absent 1 plus I. Here absent 1 minus I. Multiply. Both are same. X is the x square. 1 plus I, 1 plus I, 1 plus I whole square. 1 minus I, 1 minus I, 1 minus I whole square. Denominator a minus b, a plus b. That is a square minus b square. Here a square minus b square. Keep in your mind, I square value is what? Minus 1. This value is what? I square value is what? Minus 1. This is I square value. I square value is what? Minus 1. Minus plus. 1 plus 1 is 2. Numerator a square plus b square plus 2ab. This is a plus b whole square formula. This is a plus b whole square formula. This is a minus b whole square formula. A square plus b square plus 2ab minus, keep as it is, a square b square minus 2ab. I square value always minus 1. I square value always minus 1. Plus 1 minus 1 get cancelled. Plus 1 minus 1 get cancelled. Plus 2y minus minus plus 2y. 2y, 2y, 4y. 2 ones are 2 twos are. Modulus of 2y is what? 2. This is the 2 marks question.